So Summer Physics 3-4, this is your day 13 lesson, and it's going to be a brief lesson on electromagnetic waves. So what is an electromagnetic wave? An electromagnetic wave is a type of transverse wave caused by atoms producing a wave that is part electrical and part magnetic. Electromagnetic waves are the most common type of waves in the universe. All of the energy we receive from the sun is in the form of electromagnetic waves. Electromagnetic waves all travel at exactly the same speed in a vacuum, and that's the speed of light. A vacuum, by the way, is a place where nothing exists, not even air. So all electromagnetic waves travel at that speed, the speed of light. The speed of light is 300 million meters per second, which is 186,000 miles per second. To put that into perspective, that's 7.5 times around the Earth in 1 second. The speed of light is represented by the symbol small c. And one thing that Einstein, of the many things that Einstein discovered, it was that the speed of light is the universal speed limit. Nothing can go faster than the speed of light. So here is a diagram. It's called the electromagnetic spectrum, and it shows you all of the electromagnetic waves. And all of the electromagnetic waves are absolutely identical in what they are and what they're made of, an electrical part and a magnetic part. The difference is their wavelength and frequency. The waves over on the right, which you see where it says radio waves, have a longer wavelength and a lower frequency. They don't go up and down as many times, and you can see that diagram up at the top. The waves over on the left, where it says gamma rays, have a shorter wavelength and a higher frequency. Now remember, we said that wave speed is when you multiply the frequency and the wavelength together. For electromagnetic waves, those two numbers, the frequency and the wavelength, must equal the speed of light, 300 million meters per second. So if your wavelength is longer, that is a bigger number, then its frequency must be lower, a smaller number. And if your wavelength is shorter, a smaller number, then its frequency must be a larger number. And those two numbers, in the case of any electromagnetic wave, have to multiply out to be the speed of light, 300 million meters per second. So let's kind of look at this spectrum. If you start over on the right, you have the longest wavelength and the lowest energy waves, and also the lowest frequency waves. Those are called radio waves. The radio waves are not sound waves. Don't think that they're sound waves. They're not. They're the kind of waves that an antenna from a TV or a radio station would send out. Not that many people get their music that way anymore, but back in the day when people used transistor radios, they would pick up radio waves. If you go a little bit higher, you see infrared. Infrared are the waves that are put out by heat. And that's how we get our heat from the sun. Because remember, the waves that come from the sun can travel through outer space where there's no air, no medium. And so that's how our heat from the sun comes to us. Now, by the way, there is another type of wave that's not shown on this particular electromagnetic spectrum that you're familiar with or that you've heard of. It's called microwaves. Those are in between radio waves and infrared waves. Now, up above infrared is a little sliver you see there. And that's visible light. Those are the waves, the only waves that stimulate our eyes, the nerves in our eyes, so that we can actually see light and see various colors. So what they've done is they've expanded it out. It's that little tiny sliver in between infrared and ultraviolet, but they've expanded it out down below. And the longest wavelength, lowest frequency light waves are red. The highest frequency, shorter wavelength are violet. Those are the ones over on the left of that. And all the other colors of the rainbow are in between those two. So that's visible light. All the other types of electromagnetic waves hit you in the eye. Okay, they come from the sun, they come from other places, they hit you in the eye, but they don't have the right frequency to stimulate the nerves in your eye, so they don't create any visible light. You don't create the sensation or get the sensation of light. Only frequency that'll stimulate the nerves in the back of your eye are the visible light frequencies. Now, to the left of visible light, you see ultraviolet. And what that means is ultra means above, and it means above violet. So you see the visible light, violet is the highest frequency of the visible light. So if it's above violet, it's called ultraviolet, and that's a form of light as well. Then above that is X-rays. and then above that are gamma rays. Gamma rays are the highest energy type of waves. Highest energy, highest frequency are on the left. Lowest energy, lowest frequency are over on the right. That's radio waves. By the way, NM stands for nanometer. It is 1/1,000,000th of a meter. So this entire image, this graph here, is called the electromagnetic spectrum. So the 6 major kinds of electromagnetic waves from longest wavelength and lowest frequency are radio waves. Those are used by radio and TV stations to send over-the-air signals. Infrared waves, those are put out by anything by heat. If you've ever seen the night vision that the police or military use, and they when they show a person, when they are focused on a person, they seem like they're glowing. The person seems like they're glowing. That's called their heat signature. So that's what infrared waves put out. Or infrared waves are put out by things with heat. Visible light, that's what we can see with our eyes. Then there's ultraviolet. X-rays, those are used by doctors and dentists. The reason is they're strong enough to penetrate your skin, but not your bones or your teeth, and therefore they show your bones and your teeth and where you have cavities or fractures in your bones. And then gamma rays are the highest energy waves. They actually can go right through your body. So the lowest frequency, longest wavelength are radio waves. The highest frequency and shortest wavelength are gamma rays. And the frequency and wavelength of all electromagnetic waves have to multiply to be 300 million meters per second, the speed of light. Okay, so how are the electric and magnetic fields related? So in an electromagnetic wave, the electric part and the wave travels at a right angle to the magnetic portion. So that wave is traveling from your left to your right as you're looking at that picture. And you can see the electrical part is going up and down like a roller coaster. And the magnetic part is turned sideways. It's at a 90-degree angle. It's also going more or less back and forth, back and forth. It's following the electrical part, but it's at a 90-degree angle. It's at a right angle. So what's the relationship between wavelength and frequency in an electromagnetic wave? So there's the wave speed equation that we saw before. Now remember, all electromagnetic waves travel at 300 million meters per second in a vacuum. This means that the wavelength and frequency of the electromagnetic wave are related by the equation. And there it is. There's the wave speed equation, except the velocity is always going to be the speed of light for an electromagnetic wave, 3 times 10 to the 8th meters per second. So lambda, the wavelength, and f, the frequency, have to multiply to be 3 times 10 to the 8th meters per second. So here's a simple problem. What is the frequency of a radio wave where lambda, the wavelength, is 1 meter? So it's asking for frequency, f. There's the velocity, which equals the speed of light, which is 300 million meters per second. In scientific notation, that's 3 times 10 to the 8th meters per second. And the wavelength is 1 meter. So you solve that for frequency, so there's a little algebra step involved there. So frequency equals the speed of light over the wavelength. So that's 3 times 10 to the 8th over 1, which equals 3 times 10 to the 8th hertz. So that's how you can figure out the frequency. You just have to remember that the wavelength and frequency always have to multiply to be 3 times 10 to the 8th. So here's a summary of the different types of wave we've talked so far in this unit. Transverse waves move up and down. Electromagnetic waves are the most important kind of transverse wave. And the 6 different types of electromagnetic waves are gamma rays, X-rays, ultraviolet light, visible light, infrared wave, radio waves. The highest frequency are gamma rays and energy. The lowest frequency and energy are radio waves. Longitudinal waves move back and forth. And sound waves and springs are the most common kind of longitudinal wave. Alright, and that takes care of this lesson on electromagnetic waves, and we'll have one more lesson in this unit dealing with some of the properties of waves.